So this is the electrical protection of generator and transformer. For the generator, some of the protections are written here: generator differential protection. So these are its standard abbreviations. 87G. So 87 digits is in number is especially for the differential protection. If it is written here G, it is for the generator. If it is written here T, for example, in below 87T, it is for the transformer differential protection. And 46 is for the stator current unbalanced protection. Mean when in the on the three phases of the stator, if there is unbalanced current, so for that, measuring the unbalanced current limit and trip the mean the opening the breaker of the generator or isolating the generator from the system, we have the protection 46. The stator overcurrent is standard 51G and 50 and 51G. So both are for the stator and transformer over protection. So these are the standard abbreviations written over here. You can memorize or you need not to memorize. But even then you have to know what is the meaning of the and how is it working. For example, this in this slide, I will show you the generator differential protection 87G. So this document is included in your book. So please consult your book. I will explain it here. And please read carefully these pages. And this is the principle of the operation of 87G in the differential protection. This is the generator, and this line is coming from the neutral side, and this line is going out of the generator toward the step-up transformer. Similarly, in the below, you can see here diagram. This is the protected area, and this is the generator, and this is the neutral side of the generator, and or the start point of the generator. On the start point, all the one end of each three-phase single coil they are connected, and star point has been created and grounded. And these are the output terminal side of all the three phases. So at a time, because this is an alternating current and it is having the three-phase current, so sometimes some phases are positive. For example, in this example, I show you the arrow is going outward direction in here. Second also in going outward. And here again. And third one is inside. So it means that the current which is coming back from the alternating system, it is passing through this coil, right? For example, this is a yellow coil, and it is passing through this neutral point and then going back to the other two phases. So that the sum of the three currents I1 plus I2 plus I3 is always same. And this current transformer, to for example this transformer and this transformer, they are two matching transformers are installed on the same phase, so that when in this phase the current is which is flowing in the from left to right, and same current will be flowing at this point also. It means that output of the CT will be same, because in one phase, either in forward direction or in the reverse direction, the current will remain same in one phase at both ends. So similarly here, we go back to the previous drawing. So these are the two current transformers. Okay. So here, for example, the current is flowing I in and current flowing I out. When these two current are equal, so it means that I1 minus I2 is equal to 0. Right? So this I1 minus I2 is flowing through this coil. This is an operating coil. I1 is flowing in downward direction and I2 is in upward direction. When I1 is equal to I2, or then I1 minus I2 is equal to 0. It means that through the operating coil of the differential relay, no current will flow. But if there is any difference between these two current, it means that I in is coming, for example, 5000 amperes, but I out is only 4000 ampere. So where 1000 ampere is going? Because this is a single coil, it means that there is some internal short circuit. So maybe phase to phase or have been attached, or phase to ground fault has occurred. So in any case, if there is a difference between the I in and I out, mean I1 minus I2, then there will be 1000 ampere difference. So that 1000 ampere will be flowing through the operating coil. So immediately the differential relay will operate. And what will do? Because this is a first class or class A generator protection. So at this protection, the generator breaker will open. The gas turbine fuel will cut off because if the generator breaker will be open only and we all keep running the gas turbine at full speed, no load. So then, because this is an internal fault, so the generator will be continually, this fault will go more, and because this is an internal fault, so the generator damage will be increased. So due to increase, to avoid this increase in the generator damage, immediately the gas turbine will trip. Of the differential protection, because at internal fault, if they occur, phase, for example, red phase and yellow phase, they are short circuited, or if due to any reason the red phase has been attached with the ground or the core. So in either case, the I1 minus I2 is not equal to zero. So then that current will be passing or flowing through the operating coil. And one more thing is that the two different phases. Same one. For example, the red phase and the blue phase, they are, there you will see the generator stator. So in this screen, you see that there are slots which are inside the core. So in each slot, there are two conductors of different phases. So it means that there are the chances of short circuiting between the short circuiting between these two conductors of the out of the different phases, because the same voltage is appearing, also the 20 kV of voltage inside the slot. So in between the slots, the insulation strength is very high. But if there is any leakages or the insulation has become damaged, so inside the slot, these two conductors, they may pass the current. It means that the differential relay will operate at that case, right? Okay, now I will go back to the protection system again. So at this protection, the not even the breaker, generator breaker must open, as well as the gas turbine must trip also, to avoid the further damage to the generator. And second protection of the generator is the current unbalance or negative phase sequence protection. So there may be current unbalancing, for example, red phase, yellow phase, and blue phase, they are showing the different currents. For example, as I show you in the screen here. Okay, in this screen, you see the generator stator current I1, I2, and I3. You see, these are the different currents. I1 is 4256 amperes, I2 is, I1 is 4256, I2 is 4383, and I3 is 4256 again. So it means that I2 is more. So it means that there is a difference in the current, and this is unbalanced current. So this is the unbalanced protection should operate. Okay, so I1, I2, and I3 magnitude must be equal in any case, and this type of unloading may occur due to system disturbances. For example, if on the transmission side, if any one conductor has been dropped to the ground, so that conductor will show very high current. So that current will be flowing from our power plant. So immediately our generator should be isolated from the system. So in this case, only the generator breaker will open and the gas turbine may be running on the full speed no load. But it can trip due to any other reason. But due to this reason, the fuel will not be cut off, or the gas turbine will not trip. Only the generator breaker will open. Okay, so through this negative phase sequence current, what is the negative phase sequence? What will happen? For example, these are the phases I1, I2, and I3. So if due to any reason I1 has magnitude has been increased, so then we will resolve these into three different components. So one component is a positive sequence component, which is rotating in the same direction in which our rotor is rotating, anti-clockwise direction. And second is the negative sequence component. So this part of the current, which is the negative sequence component, it is flowing in opposite direction. Mean rotor is rotating in anti-clockwise, but negative sequence current is rotating in clockwise direction. It means that it is affecting with the double frequency. Mean if the frequency normal is 50 cycle per second or 50 revolution per minute per second, so then this current will be producing an induction current on the rotor with double frequency, 100 revolution per second. So it means that the rotor will be quickly overheat. It depends upon the magnitude of this negative sequence component. If the magnitude has become very, very high, so it depends on upon the unbalancing of the three different currents, I1, I2, and I3. And third one is the zero sequence component. So this does not do anything, but it is used in the stator overcurrent protection. Okay, so how the gas turbine will trip or the breaker will open? In this case, the gas turbine will not trip, only the generator breaker will open. So this is a time curve for the negative sequence current I2. This is I2 is a negative sequence current. If the current is more, then the breaker will open in very short time. And when the current is less, when the current is less, then we will give more time to operate the generator with this fault. So that maybe during that time, maybe this unbalancing automatically reset, and we don't need to open the breaker. But if due to any reason the breaker has the negative sequence component magnitude is very, very high, immediately within seconds or within few seconds or milliseconds, the breaker will open. So in this case, two things will be done. One is the generator breaker will open. So second is that the excitation current will open also. Mean excitation current will off. The DC excitation breaker will open, or the current which is supplying from the excitation system that will be interrupted, and the generator main breaker will open. But the gas turbine will not trip. And on the stator earth fault, this is also is class A protection. So at this protection, the generator breaker will open, excitation breaker will open, and the gas turbine fuel will cut off also, means the gas turbine will trip also. So what is the stator earth fault? It means that the stator coil is grounded due to any reason. So it may be the similar fault as with the differential protection. But in this case, we have another set of the protection relay. So in this case, we have two types of protections: 80% stator earth fault protection and 100% stator earth fault protection. So this is for example, these are the three phases. And I have drawn two circles. One circle is inside, other circle is covering all the winding or all the generator winding. Okay, here now you will see completely. Okay. So I have drawn two circles. Outer circle is covering the 100%, and inner circle, and between the inner and the outer circle is covering the 80%. So this is the 80% winding protection. You see, if the fault occur or ground fault occurs at in the 80% winding, so then we can detect it easily. But if the fault occurring with near to the neutral point, because the neutral is already grounded, and the second from the second point of the winding, that winding is also grounded, so we cannot detect it very easily, because that fault is very, very near to the neutral point, and neutral is already grounded. So it assume that similar as the neutral is already grounded, so we cannot detect it very easily. So for that, purpose, there is another very sensitive winding protection that is called 100% winding protection. And the operating mechanism of these two protection are different. 80% winding protection is by measuring the third harmonic voltages, and 100% winding protection is operated by measuring the zero sequence voltages. As previously I have shown you during the unbalancing current, because unbalancing during the unbalancing a zero sequence component is more, you can see the zero sequence component, and by measuring that zero sequence voltages, the 100% stator at fault protection is operated. On the next slides, you will see the stator overcurrent. This is very simple. Whenever due to any reason our generator current is beyond the normal its current, then stator overcurrent protection will operate. For example, if there is any short circuit outside the power plant or in the grid system, stator over voltage means normal voltage is, for example, that is the terminal voltage 20 kV. So 20 kV, either its setting is plus 100 at 120% over voltage. So mean normal generator can be operated at plus minus 5% or plus minus 10% over voltage. Sometime plus 10%, sometime minus 10% voltage. So, but this overcurrent protection is normally operated at 20% more voltages. So that time delay only 4 seconds. In this case, the breaker will open and the gas turbine normal shutdown order will be given. Mean gas turbine will not trip, but it will go to normal shutdown. So similarly, the excitation breaker is also open. So causes of this over voltage are maybe due to the faulty operation of automatic voltage regulator or incorrect manual operation of excitation system. So for example, if AVR is on not auto, is on manual, so manually some operator may give the command to over excitation. It means that due to over excitation, the voltage may be rush and go beyond the limit. So due to that reason also, this protection may operate. Load shedding during manual operation. For example, it means that the a sudden load on the generator has been decreased. So at the same time, our generator voltage will be shoot up. Or fall in island operation mean our grid has been already is separated from the grid system. If our plant so at our plant, the voltage will go beyond the limit immediately if our generator will not control these things. But sometimes atmospheric surge voltage is also maybe cloud or due to during rainy season, a surge voltage may occur on the transmission line due to atmospheric current in the clouds, switching surge fault or instantaneous decrease in load or increase in speed. Frequency protection. So under frequency protection and overfluxing are the same. This is the voltage equation for the generator. V is equal to 4.44 BAFT. T is the flux density and F area, A is the cross-sectional area of the stator and the rotor. F is the frequency and T is the number of turns. So in this we see that we can see right the voltage is equal to C, B and F, because otherwise area and number of turns are remain the constant for a specific generator, and 4.44 is also a constant. So it means that B flux density is equal to K V or F, or B is inversely proportional to the frequency. It means that if our generator is frequency has been dropped, so it means there are the chances of overfluxing. So if we operate our generator as lower frequency or decreased frequency at the same voltages, so then the flux will be increasing in the core of the stator as well as the rotor. And because same frequency will be going to the transformer also, so the overfluxing will be occurring on the transformer also. But the overfluxing is what is due to the overfluxing, or mean the magnetic flux will increase immediately. So the generator core will be heated up, as well as the generator body and the casing and the covering will be heated up also due to the overfluxing. because the flux will go beyond the stator core. But at the generator, nothing will happen because if its body has become heated up, after that time when the this problem will reset, the generator will again cool down. But the same happens on the transformer, which is directly connected with the generator. So at that time, the transformer oil will be heated up because in the inside the transformer there is a oil for cooling of the winding. So by heating in the very huge heat produced in the transformer core, its winding as well as the oil in the transformer, it will be reach at very high temperature. So due to that reason, if there is a high pressure occurring inside the transformer body and oil is come out, then it may catch fire. So to avoid this phenomena, we have to open the breaker of generator due to the overfluxing fault. So it may also happening due to large increase in magnetizing current, mean excitation current is increased. So due to that reason, the overfluxing will occur. Or by decrease in frequency. So similarly, the reverse power. Reverse power protection is actually not for the generator, it is for the turbine. But it is occurring on the generator always. But it is why it is not for the generator? Because you know that during the startup, we are running our generator on reverse power because we are supplying the power to the generator from external source. It means that at that time there is a reverse power situation on the generator and there is no problem on the generator. It will become motor. And same if happening if the generator has been connected with the system and there is a loss of power, mean if there is a fuel has become cut off and the breaker is not open, at that time the generator will be running as a motor and it is taking the power from the system. So to avoid the system, because we are not generating now, but we are consuming the power from the system. So to avoid the system or to protect the system, our generator breaker should open immediately. Similarly, if the generator is running as a motor with the help of the power taking from the system, so it means that our motor is now rotating the compressor, and compressor is a big power, double as compared to the capacity of the generator. There is a very huge load on which has been put on the generator, and our turbine has no power now because its fuel has become cut off. So to avoid that, it means that there may be damage on the compressor also. To avoid that damage, we have to protect our generator, immediately open the breaker at the reverse power operating mechanism or the reverse power relay. So similarly, one more thing is the Bucker's relay, that is for the transformer. Because inside the transformer the winding is dipped in the oil, and oil is continuously heated up due to the winding temperature, and it is cooling the winding actually. But if due to any reason internally if there is a fault occurring, then the gases will go to the surge tank, because the surge tank is normally half filled. So whenever the oil is heated up, it is passing through this line and is going to the reservoir tank. And when the oil has become cooled down, when the transformer is shut down, then the oil will go back to the winding. So if there is any fault occurring and gases are produced, so that gases will pass through this Bucker's relay, which is installed on the pipe. So that is a mechanical type relay. This type I have shown you in this animation. So when the gases they are flowing towards the reservoir tank, they will trap inside this Bucker relay, and that float F1, which is floating on the oil, when it is filled, its chamber is filled with the gas. It means that the float will come down, and then this contact C1 will close. So when C1 is closed, so it will initiate an alarm. It will give an alarm. But if due to any reason, if a heavy gas is passing and oil is rushing towards the conservoir tank, then this float will operate due to rushing of the current of the oil. So at that time, the C2 will operate. It will trip the transformer. So what is the tripping on the transformer? because the transformer has two breakers, low voltage side breaker and high voltage side breaker. So both breaker will open at the same time. So this is tripping of the transformer. In this case, the transformer will be isolated from high voltage side and low voltage side also. But at the same time, both breaker will open and our supply will automatically change over on the bus bars. But we are concerning about the transformer only, so we have protected the transformer for that the fault should not damage the transformer more. So these were the protection of the generator and the transformers.